Okay, this lesson is on solving systems of equations. And there's some vocabulary that we need to go over first before we will really dive into solving systems of equations. And the first is figuring out exactly what an equation is. And we've mentioned this a few times in class so far. But an equation is really just any time we write an equal sign. If I write something equals something, that is an equation. And so in math we have these things called linear equations. Okay, and I'm going to start by giving you an example, and then I will expound on it. So let's say I write x plus 3 equals 5. This is a linear equation. Okay, and you can write that down. Linear meaning spelled L-I-N-E-A-R. So this is a linear equation. Well, what is a linear equation? Well, a linear equation means this: the highest ordered power in this equation is 1. The highest degree is 1. And really, when we're thinking about the degree of an equation, we're looking at the variables. Okay, so these terms that have a variable, and what exponent or power that variable is raised to tells us whether it's a linear equation or not. For example, it's not written there, but there's a 1 right there, that this is x to the first power. Because the degree of this equation is 1, because its variable is only raised to the first power. And when the degree of an equation is 1, that is what makes it linear. Okay, so I'll say that again. When the degree of an equation is 1, that's what makes an equation linear. So for example, if this were to say instead x squared plus 3 equals 5, the degree of this equation is 2 because the variable here, the degree of that variable is 2. Okay, so this would not be a linear equation because the highest ordered term, the variable, is raised to a power higher than 1. So this is not linear. And so I'm going to erase that. So that's a short kind of definition of what a linear equation is. And solving linear equations is very simple. You see we have these two here. These are both linear equations. Why? Because in each case, here we're going to say that A, B, and C are numbers. So we're going to see A, B, and C stand for numbers. Those are called coefficients, and I'll write that out, are coefficients. And what that means is they're really just numbers, but we're going to use variables to refer to the numbers. So here, our only variable that is our unknown is actually x. A, B, and C can be any number. So this is order 1. This is order 1, the degree of 1. And we can solve these really easily. What am I going to do to solve this? I'm going to subtract 5 from both sides first. That crosses out over here. This 3x comes down. 11 minus 5 is 6. And then I need to divide both sides by 3. And x equals 2. And you know how to do this. This is what algebra is. That was about as simple of an algebra problem as you can. That's solving one linear equation. Here, if I were to ask you to solve this for x, you would literally do the exact same steps, right? Here, instead of 3, 5, and 11, what we're basically saying is, well, A, B, and C could be anything. They don't have to be 3, 5, and 11. It could be, I don't know, 5, 2, and 1. It could be 7, 49, and 30, right? That these numbers could be anything, but solving it would be the same. So what did we do first? If we were to solve this problem here for x, if we were to solve this linear equation for x, we would need to subtract b from both sides. So I'm going to subtract b. And over here, those cross out, and what's left is just ax. And over here will be c minus b. And then what do I need to do to get x by itself? I need to divide both sides by a. They will cross out, and what x will end up being is x is going to be c minus b over a. Okay, so if I want to, I could solve for x, and I could solve for x really easily in a linear equation. But what about when we have multiple variables? So what if we have like this here, x plus y equals 3. That is actually unsolvable. Why? Because there are two unknowns. I cannot solve one linear equation when there are two unknowns. But what if I know more than one statement about x and y? So let's say we have x plus y equals 3, but let's say we also know that x minus y is 1. Both of these statements are true. How would I solve this? Well, let's think about this for a second, really quickly. You probably know or remember how to graph an equation of a line. And graphing an equation of a line is really simple. I need to get, in order to graph a line, we would need to put it in y equals mx plus b form, where x and y are actually x and y values, m is the slope, and b is the y-intercept. And we went over that earlier, so this should all be familiar to you. But what does this actually mean? Like, if I were to ask you to solve this, you would have to plug in x and y values so that they would equal 3. So like, let's say if I plugged in a 3 for x and a 0 for y, would that work? Of course it would work. 3 plus 0 is 3. So I could come here to this xy graph and go 1, 2, 3. I'm going to go 3 in the x direction because x is 3. 0 in the y direction. That point would work, but that's just one point. Are there any others I could do? Well, what about the opposite? What if instead x was 0 and y was 3? 0 plus 3, that would equal 3, so where I need to go where x is 0 and then y is 3, that's right there. So both of these points would fit into this equation, but you should be able to figure out that there are actually infinitely many points that would fit into this equation. I could keep going forever and ever and ever and figuring out I could do 6 and -3, I could do -3 and 6, so on and so forth. And that is actually where we get this line from. So if I were to rearrange this to get it in y equals mx plus b form, it would look like this. Y equals -x plus 3. Okay, and I could graph this line, and let's do that now. This is the y-intercept, so there's plus 3, and then it's just y equals, the slope is -1 over 1, so I'm going to go down -1, rise over 1 over 1, down -1 over 1, so on and so forth. And then you could see the equation of my line appearing there, and I'm actually going to graph this line exactly just to make sure that it's okay. And then let's extend this. Good. So there is that line, roughly. That is this line right here. Y equals -x plus 3. And you can see that there are a lot of different values. What this line represents is every point on this line I could fit into this equation, and it would be two numbers that would work, that would equal 3. But we don't just know that x plus y equals 3, we also know that x minus y equals 1. So when I change that to y equals mx plus b form, I get y, and you can do this if you want, or you can just trust me, y equals x minus 1. So now I'm going to graph this line in red. My y-intercept is -1, and my slope is 1, so 1 over 1. So 1, up 1, over 1, rise 1, run 1. And then once again I will graph this line really quickly. Okay, so here are these two lines, and here's what we see, that yes, there's plenty of points on both of these lines that I could fit into each of these individual equations on their own. There are like 3 and 0, like 0 and 3, like 6 and -3. There are tons of points I could plug in to get x and y equal to 3. Similarly, as you can see, what this red line represents are all the points on this line that I could plug into this equation to make this equation equal to 1. Like 1 minus 0. If I go to x equals 0 y equals, I'm sorry, x equals 1, y equals 0, that's that point right there. But there's only one point, and it's right there, where both of these lines come together, where both I have x and y values that would fit into here to make this equation 3, and here to make this equation 1. There's only one point, and it's right there, and you can kind of see what that is. It looks like this is about where x equals 2 and y equals 1. So it looks like if I just graph these lines, that the point where both of these lines would be true, where both of these statements would be true, where x plus y equals 3 and x minus y equals 1 is where x is 2 and y is 1. And if we just plug these in, if x is 2 and y is 1, then x plus y does equal 3. If x minus y equals 1, 2 minus 1, that does equal 1, so that would work. But there's only one point where we can do that, and that was a lot of work just to get to that point where we could see this. So do we have to graph every time to figure out exactly what this point where they intersect are? No, we can actually solve, we can use some methods to solve these systems of equations, and that's exactly what this section is about. And they are called substitution and elimination. Okay, so we're actually going to learn substitution and elimination, but we're going to learn it in the next video. The point that I wanted you to get here is that there is only, when I have systems of equations and I know two statements that are true about two variables, x and y, there is only one point where they can both be true. And what we're trying to do is solve where that point is. Solve what values I could plug in for x and y to make multiple statements be true.